Hi, I'm Chris Lauren, and I'm here to talk to you today about Visual Studio Tools for AI. It's an exciting new extension that you can download for free, install in Visual Studio 2015 or 2017, Community Edition or better, to include AI in your applications today. I'm going to walk you through a couple of things. I'm going to show you how to train a deep learning model using Visual Studio Tools for AI on your local machine so you can rapidly debug your code. You can set breakpoints in Visual Studio. And then once you're happy with the quality of the model that you're getting, you can scale that out to the cloud using Azure Deep Learning VMs, using Azure Machine Learning for any of the remote compute contexts like HT Insight or others. And you can even use Azure Batch AI, which enables dynamically scaling up and scaling down VMs for you, so you're only paying for them while your jobs are actually running. Finally, I'm going to show you how to download that trained model and include it in your application super easily. Let's get started. I'm going to show you how to use Visual Studio Tools for AI to recognize handwritten digits like you might find in a check scanning device. We're going to use the MNIST dataset, which is kind of like the hello world of machine learning. It has a bunch of handwritten digits that are individually labeled so we know exactly which number is which image. Now to do this, we convert the image to a set of 28 by 28 pixels and represent that as a bit array so that the machine can quickly process and understand that this number 3 is corresponding to a particular byte array. Now historically, to build an application to recognize those digits, I might have told the machine exactly, step by step, how to interpret those images. But instead, with machine learning, I provide a bunch of examples that it can learn from. Historically, I would write this in code to implement this intelligent function, but instead, I'm going to create a model that I can include as a resource in my application. So just to recap, to train my model, I'm going to identify some input data sets. Initially, when building a model, it's important to explore the data set. You need to make sure that you've converted it to a way that your machine can properly process it quickly to generate the model, which you'll then use to predict, in this case, which digit is being written in a handwriting recognition application. So I'm going to show you how to use Visual Studio Tools for AI, how to do this. In Visual Studio Tools for AI, we've made it super easy to get started by integrating with Azure Machine Learning. Find a wide variety of project templates using CNTK, TensorFlow, Spark, and more that you can simply click Install and get going today. However, I already have my own code, so I'm going to open that up, and you can see this is simply a Python file that I can set a breakpoint and step through and debug using the power of Visual Studio Tools for Python. I can step through, and you can see my model is updating. Now we can go ahead and click Continue, and this will proceed with training my model on my input data. And I can see this key metric, which measures the error rate of predicting which digit was in the handwritten example, because I have two input data sets, a training data set and a test data set, which is super important because you would always use unit tests when writing code. We use sample data sets to test the quality of the model. Now, we can visualize the loss or quality using built-in TensorBoard integration. And over time, you can see that the quality is getting better and better because the loss is reducing over time. However, as I told you before, training on more data always beats better algorithms, so I'm going to submit my training job to the cloud using an Azure Deep Learning VM that I had configured previously. Now, I'm going to give my job a name, and I'm going to import a config file so that I don't have to remember to type things like MPI exec every single time, even when I want to run over multiple GPUs. So I'm going to submit my job, and we can see that my job is running. Moreover, even though the job is running on a machine in the cloud, I can get quick access to the standard error preview and standard out and the working folder as well. So as the job is making progress, I can easily monitor it. I can also see that the job is running on all 4 GPUs using the integrated heat map. If I'm impatient and like to watch the GPUs run, I can change the refresh interval rate. And I'll point out that if you don't want to leave your GPU VM running all the time, we've integrated with Azure Batch AI, so you can submit your job to the cloud and it will only use GPU VMs when your job is actually running, because it automatically spins up and spins down your machines. Now, you can see that the job is done. The GPUs are not being used anymore. And in fact, I can see that the job is completed. So I can click Working Folder and look in the output directory and grab my digit model file. And I'll put that in my data folder here. And as you can see, I've already included the digit model file in this application. To use the model to actually do inferencing, we simply load the file, and then we will take the input data of the image, the handwritten image, and output the image digit prediction. So by running this application, it'll pop up my app, and I can simply write a 3. We'll click Recognize. And if you look in the output data, you can see a level of confidence, if you will, that it's pretty darn sure that that really was a 3. I'll continue to run, and that'll output a 3. I can clear the digit and write a couple of others. And it has, again, the level of confidence, and we'll output this. And it's, again, confident that it's an 8. Because we've integrated Visual Studio's tools for AI with Azure Machine Learning, I can easily scale out my model not only to train it, but also to deploy that model to a wide variety of use cases in Spark, in SQL Server, on-premise, and more. So as a wrap, you can download Visual Studio Tools for AI today for free in Visual Studio 2015 or 2017, Community Edition or better, and we even have a similar extension available in Visual Studio Code. So if you prefer VS Code, a cross-platform solution, please download that today as well. Give it a try. Learn more at these links. Thank you.